Hello, thank you for joining me. I'm going to be getting the discussion started on boundary analysis. In healthcare, we're constantly facing complex problems that we need to sort through, and this is similar to facing a huge heap of garbage in search of valuable items. It can be hard to know where to start or what direction to take. But boundary analysis is a tool that provides us that starting place and gives us the structures we need, like a garbage can to collect the most important problem representations, and a lid to stop adding once we have a complete representation. The first step is building the pile. This happens as multiple trucks bring their individual loads to the dump, whether it be residential, business, industrial, or other waste. All is required. Boundary analysis starts with seeking out all relevant stakeholders. You begin with those who you know have competing perspectives to the policy claim, and you ask them to identify two additional stakeholders who support and refute the claim. You continue on in this process until no new stakeholders are named. At this point, you have reached saturation of stakeholders. Then engaging with these stakeholders through interviews, conversations, document review, you start to create the pile of alternate representations of the problem. In the final stage of boundary analysis, you plot the problem representations on what's called a Pareto chart, which highlights the most frequently occurring representations. According to the Pareto principle of the significant few to the trivial many, it is generally those significant few that account for 80% of the problem. It is at this point that you can stop sorting and put your lid on your can. Some of you may have heard of or applied the 80-20 rule when you're looking at issues and wondering or considering if they're overriding versus infrequent. Overall, boundary analysis gives us the structure to collect what's most important out of a huge heap of garbage. It allows all the trucks to contribute, maximizing all stakeholders and contributions to the pile. As a problem structuring tool, however, it does not provide absolute certainty, but it can help us to reduce the risk of a type 3 error of solving the wrong problem. As I looked for application of this in the healthcare environment, I didn't find any examples that referred to boundary analysis explicitly. In the Hanstein and Fanning resource, some elements of the tool were evident, but rather than using saturation of stakeholders, they used brainstorming amongst a set group of program staff to elicit the problem representations, and those were then plotted on a Pareto chart. We've talked about how the tools and methods that we're going to be looking at can be used at various stages in the policy analysis process, and Rees et al. Provide an interesting application as a tool for prospective monitoring of problems related to vaccinations. They used a centralized incident reporting system to identify problems from multiple centers. Those were then plotted on a Pareto chart and allowed them to identify factors from multiple centers that wouldn't have been evident looking at the individual centers in isolation. In my own experience in the healthcare environment, I have not come across the formal application of boundary analysis. I can definitely see benefits and challenges to using this tool, and I can also think of a few limitations. And I look forward to your insights on this in the discussion forum. Thanks for joining me.